This is the notes for AP Physics and Physics students on how to solve circuits. So our example is we have one resistor, which is 2 ohm. We have another resistor, which is 6 ohm, another resistor, which is 2 ohm, another resistor, 2 ohm, and one resistor, 2 ohm. And the voltage is not given, but what is given is the current. The current is 9 amps. So to solve this problem for the unknown in the given circuits, at first I'm going to look at the current and I'm going to say, so I do not know how much voltage I have in the source, but the current, as I show, goes from positive to negative. So my current leaves 9 amps. Sometimes we call them in the classroom 9 aliens, leaving the battery. Battery is their home. They pass through the first bridge, the first resistor, and they will drop some of their money. So some of the voltage that they have, they're going to drop here. So when they leave the house, they always have something in their pocket to spend. And how much they spend is how much voltage they have. We do not know how much they have, but I see right here they will drop 18 volt because the Ohm's law says V is equal to I times R. My I is 9 and my R is 2. So the voltage dropped on the first resistor is 18 volts. And then it gets too complicated. I cannot solve the equation of the circuit after this because it just too much stuff over there. So I'm going to start simplify. So the way I always look is I always look and check for parallel connections first. And here I see one resistor is connected parallel to the other, so I can get rid of them. This resistor is not parallel or series to anything right now because for series, it has to have the same current, and this current is not going to be the same as this current, and this current is not going to be the same as this current. And this resistor is not parallel to that or this because they have to share two nodes in between them. And this one doesn't share any nodes. So these two resistors do share these two nodes, then they are parallel. So in order to find the total resistance of two parallel resistors, I want to replace them with one resistor. I'm going to do 1 over, the result flip over. So I have 1 over 2 plus 1 over 2 gives me 2 over 2. Even if I flip it, still 1 ohm resistor. So I do 1 over, the result flip over. So I have a new circuit now. I'm going to replace these two resistors with one resistor right here. I have highlighted in purple. And I say the total resistance is 1 ohm. And when I look at here, now, since I simplified one of the parallel resistors, I look and I see series connection. So between A and B, the point CD, go back to it here. My point CD replaced in between 2 point CDs, I had two resistors, and now I have one equivalent resistor, which is 1 ohm resistor. So my D actually here and there, D and B is exactly the same point because they don't have any resistor between them. It's just having a wire, which is the same point. So between C and D, now I have 1 ohm resistor. I still have 2 ohm resistor right there. And I see now that this 2 ohm resistor and 1 ohm resistor, they are in series because the current that is going to go this way is exactly the same current that is going to pass through this new resistor. So because they are in series, I'm saying now I see R between A and C and R between C and D are in series. So I'm gonna add them together for series connection. I just add them together. Then I have 2 plus 1 is equal to 3 ohm. So instead of this whole cloud of green color, I'm gonna replace it with one resistor of 3 ohm. So I'm gonna throw these two resistors away and place one resistor of 3 ohm. And my circuit looks a little bit easier now. Now I have two resistors in parallel. So every time you look at the new circuit, you continue solving like if it was a new circuit. So I see this and this. By the way, my C disappeared somewhere in between because I cannot show my C anymore. I only have A and D, and I have A and D. Everything that was between A and D became one resistor. So now I see that my new resistor is parallel to the 6 ohm resistor, like this resistor or this resistor. You see, like I simplified all this thing to just one resistor. So I see them in parallel. They share two nodes. And I can do 1 over 1 over, the result flip over. So that gives me the total resistance right here is 2 ohm. And I can just throw these resistors away, and I can make a new resistor, which is 2 ohm. And when I look at the new circuit, I see, oh, well, this is easy. Everything is in series now. Because it's in series, I have 2 ohm resistor, 2 ohm resistor. My total resistance becomes 4 ohm. And so my total resistance in the circuit is 4 ohm. So I know the current is going to flow the same through both of these two resistors. So that gives me that my voltage is actually 36 volt. My source is I times R, and R is 4. That gives me 36 volts. Now, I would start going back this way to do the work, but it's going to be too confusing if I continue writing a lot of stuff in the circuit. So I'm going to continue passing by this way. So what I see here is here is my resistor, right? So I'm redrawing exactly the same circuit. So I have here my two resistors, and I just found out that this is 36 volt, and the current is 9 amps. But current times the resistance gives me the voltage. So I times R will give me how much voltage I lose right here. So right here, I'm going to lose 18 volts. But I only had 36 volts. So I need to spend over the first bridge 18 volts, over the second bridge the rest, and come back home. So that means I'm losing here also 18 volts. So the voltage between A and B, the voltage between A and B is also 18 volts. I have it right here. Now I'm redrawing back. I used to have this 2 ohm resistor, and I got it. If you go back right here, I got this 2 ohm resistor from these two resistors, 6 and 3. So I have right now 6 and 3. And I'm looking for the voltage. So I know here is 18 volt, here is 18 volt, and back home to 36 volt right here. So if I have 18 volt here and these two are in parallel, then they share the same voltage. So the voltage divided by this resistor gives me this current, and the voltage divided by this resistor gives me this current. And the total current between these two should be what I used to have before. If there are 9 aliens left the house, all 9 passed through the first bridge, but not all 9 went this way and not all 9 went this way. 3 of them actually went this way. They passed this bridge, they paid 18, and they got home. So those 3, they paid 18, went back home. The rest of them, of 9, decided to go this way. So they will pay also 18 and back home, because I times R will give me the same 18. Now, coming back to the new resistor. So this one is 3 ohm resistor. And I got it from having 1 and 2 ohm resistor. So if we go back right here, you see I have my 2 and 1 ohm resistors, and I got it from these two. So I'm going to replace this 3 ohm resistor back to 1 and 2. So this is what I have right here. I'm replacing my 3 ohm resistor into 2 and 1. So now I look this way. I have 9 ohm resistor. I lose 18. 3 of them went this way, and they lost 18, went back home. All 36 is spent. And the rest of them, 6 of them, we decided, right? 6 of them right here. 6 of them will go that way. 6 of them go this way. Oh, but now there's a resistor. So every time they pass the resistor, they have to pay. How much do they pay here? 6 times 2 gives me 12 volts. But between this point and this point, they have to spend 18. So if they spend the 18 between this point and this point, they have to spend 18 between that point and this point. Because here they spend 18, they spend 18 back home, or they spend 18, they spend 12, they have to spend 6 more and back home. So that means the voltage between points C and D is 6 volt. So now I know, back to the original equation, or the original circuit, you see right here, back to the original circuit, between the voltage between C and D is actually 6 volt. So if the voltage between C and D is 6 volt, then the current through this one 6 divided by 2 gives me 3 amps. And the current through that one, 6 divided by 2 gives me 3 amps. So this is what I have. I have 9 aliens left. They will span 18 volt because 9 times 2 gives me 18 on the first resistor. 3 of them will go this way. 3 times 6 gives me 18 volt. They will spend the rest 18 and get back home. 6 of them decided to go this way. So from 9, 3 went this way, 6 went this way. They spent 12 volt on this resistor. So only 6 left between these 2 points. Some of them went this way and some of them this way because the resistance is the same currents went through them. Not the same aliens. Just because here are 3 aliens and here 3 aliens does not mean these are the same 3 aliens. So in series connection circuits the resistors will have the same current. This one is the same number but not the same electrons that are running through each resistor. And here is the solution for this problem. That is it. We found that this current was 3 amps. This voltage was 18. This was 36. This current was 6. The voltage drop here is 12. This voltage is the same, 6 volt, and the current was 3 and 3. And that is all you needed to know how to solve circuits. I took one of the most difficult ones from the lessons that you have, but I wanted to go, and you have this in the notes. And you also have more videos related to this online. So I have this for you solved as well with a different explanation. I just thought I would post this additional to the notes.